the first thing is just looking at the general form of an exponent. Okay, so the exponent is going to have this base a to this exponent, okay, which is your power of n. And what the exponents simply represent is repeated multiplication. Okay, so it's taking this base a times itself a total of n times. Okay, and so you should all be familiar with exponents. Okay, and these are the rules that are associated with exponents. Okay, first is the product rule. What that states is if you have the product of two exponents, so a to the m times a to the n, then what you can do is you can combine those into one single base a, and you add their powers, m plus n. Okay, so the idea would be something like this. 7x times x squared is equal to x to the what? X to the ninth. You just add them together, and that gives you your power. Okay, the quotient rule, a similar idea, is if you take two exponents and you divide them, as if they have the same base, a in this case, you can combine them into one single exponent with base a, and here you would subtract their powers. Okay, so something like this would be x to the 7th over x squared is equal to x to the 5th. Now, oftentimes, instead of looking at this as 7 minus 2, many of you will just use canceling, right? So these two x's cancel with two of these, leaving 5 up here. It's the same idea. You're really just subtracting the powers, but you can think of it as canceling as well. Okay, the power rule is if you take a power to a power, meaning you have this exponent, okay, and you take it to a new power, or new exponent, what you can do here is write it as one single base a, and you can multiply their powers, m times n. So once again, if you take x to the 7th and you square that, it's equivalent to taking x to the what power? Just multiply, you get x to the 14th. Okay, the zero exponent rule. Okay, if you take any power or any base to the power of 0, that's always going to equal 1. Okay? The only extra condition is the base itself can't be a 0. Okay? But it can be a positive number, a negative number. If you take it to the power of 0, okay, then your overall value is 1. Okay? So if you have x to the 7th all to the 0, you can use the power to a power rule. You get x to the what? Power to power, you multiply x to the 0, and x to the 0 has a value of 1. Okay. The one place where you want to be careful on this would be something like this. Okay. If you have negative 3 to the 0, okay, you have to be really careful with what is your base. Okay. Because when you look at this, negative 3 to the power of 0, that power of 0 is only attached to the base it's connected with. If there's a sign in front of that, unless there's a grouping symbol about it, which comes down here to this rule that we'll talk about in a moment, this power of 0 only applies to base 3. The negative out front is a separate operator. It's basically saying minus 1 times 3 to the 0. So the order of operations say you do exponents before you multiply. So you get here negative 3 to the 0 is a negative 1. So you do want to be careful in that situation. Okay, the next rule is the negative rule for exponents. If you have an exponent to a negative power, that negative power doesn't change the sign, and that would be the most common mistake. Okay, the negative power simply inverts the base. Okay, so instead of the a being in the numerator, the a, base a, gets moved to the denominator, and you change the sign of the power. Okay, you can think of it in this way as well. If your negative power begins in the denominator, that negative power is going to move it from the denominator up to the numerator, and so this becomes a to the n. Okay, So x to the minus 7th is just going to take that base x, move it to the denominator, change the sign to positive. Okay, the power of a product rule says that if you have a product of two bases, a times b, inside an exponent, or as the base of an exponent, then that power of m, the exponent m, is going to apply to each individual base. So this becomes a to the m times b to the m. And so what this might look like would be something to this effect. If you have the product 2x all cubed, the cube is going to apply to both the 2 and to the x, which you could then simplify completely. Okay, so a power applies to all factors inside of a product. And there could be more than just two factors too. It applies to every single one. And really it applies to every factor in a fraction. So a numerator factor or a denominator factor. If you have a fraction a over b to some power m, that power of m is going to apply to both base a and base b. Okay, so if you had something like this, x over 2 cubed, then that power of 3 is going to apply both to the x and to the denominator 2, which once again you can simplify completely. Right, now, occasionally in what you'll see in some of the homework problems, you're going to be given each of these rules separately. But more than likely, these rules all apply together in values or expressions that you have to manipulate. Okay, so you might see something like the following doing. Okay, but what I'm going to do is I'm going to kind of use this power of a product rule first. So I'm applying my power of negative 2 to each of these. Okay, so my 9 squared gets moved to the denominator. The z cubed to the negative 2 is a power of a power. So I'm going to take 3 times a negative 2 is negative 6. So I have z to the minus 6. That moves my base to the denominator. I have z to the 6th. And then I'm left with my y up top. So that's kind of going through my whole numerator. I'm now going to go to my denominator. I'm going to apply this power of negative 3 to all elements, all the factors inside. So I have 2 to the minus 3 moves my base up top. So I get 2 cubed moved to the numerator. Y to the minus 3 gets moved to the numerator, becomes a y to the positive 3. And x to the 0, 0 times negative 3 is 0. Anything to the 0 power is a 1. So the x just is left out here. My final step would be to simplify everything I have. So 2 cubed is 8. Y times y to the 3rd is my product rule. I have the same base, so I add their powers. The unwritten power is a 1, so 1 plus 3 gives me y to the 4th, all over 9 squared, which is 81, z to the 6th. And this would be my solution. Okay, when you're entering these online, you can either use the equation editor, or if you were entering this, you'd put 8y to the 4th, all in the numerator, divide by the denominator, 81, z to the 6th, close that off, and this will give you, in your preview, the exact answer, or this exact form that you see right here.